This FRQ from the practice exam for 2070 concerns a piecewise function. It's a non-calculator exercise and there are 4 questions. As soon as you see a question like that, and they are quite rare, you need to immediately think that, okay, this may be a problem at x equals 0. Most questions are going to be about x equals 0, and I'd better know what's going on. Even without reading the question, you can almost assume that there will be a question about whether this function is continuous at x equals 0, and if it is continuous, then whether it's differentiable. So let's see what they have in store for us. Question A, is f continuous at x equals 0? Justify your answer. So exactly what we assumed. And for a function to be continuous at x equals 0, the limit from the left, using this rule, and the limit from the right, using this rule, have to be equal. So student A writes it like that. Is it true that at x equals 0, the right rule or the left rule will equal the right rule, and they find that on one hand it's equal to 0, and on the other hand it's equal to 3. So f is not continuous at x equals 0, and this here is very important. Just finding that earns a point, but if you can't explain, if you can't justify your answer using limits, using calculus concepts, you're not going to earn the second point. So this part is very good. The limit as x approaches 0 from the right is not equal to the limit as x approaches 0 from the left for the function f. 2 points for student A. Student B does it even better, I think. They write it like that. The limit of f of x as x approaches 0 from the left is 0. The limit of f of x as x approaches 0 from the right is 3 by plugging it in, basically. And therefore they conclude correctly that f is not continuous because the one-sided limits disagree. I think this is probably as good as it gets in terms of student's answer. Student C doesn't explain correctly. Yes, because differentiable. We'll maybe get back to that a little bit later. And the idea that a function is continuous when it is differentiable is true. If it's differentiable, it's automatically continuous. But it happens that this function is not differentiable, so there was no way that student was going to earn points. And anyway, there's no explanation of why that function is differentiable, so it was not a good answer. Question B. Find f prime of -2 and find f prime of 3. Student A calculates f prime of x, and they differentiate the first rule here. The derivative of 3x squared plus 2x is 6x plus 2, and the derivative of e to the 2x plus 2 is 2e to the 2x. Now I'll talk later about this here, because there's a little mistake. But then the student uses the right rule. For -2, they use 6x plus 2, so f prime of -2 equals 6 times -2 plus 2, and the answer is -10. And for f prime of 3, it is 2 times e to the power of 6, so that is correct. So the student earns both points, but there's a little mistake here. In fact, because f of x is not continuous, as we've shown in the first question, it's also not differentiable. So we should really just write x strictly less than 0 with no equal sign. So x equals 0 is undefined for the derivative. F of x is not continuous at x equals 0, therefore it's not differentiable. They didn't take a point off for that because the aim of this question was unrelated to that detail. And in fact, in question C, the question will relate to that, and we'll see that this student A, did question C correctly. So they probably understood what they were doing, they understood that they had to be careful at x equals 0, but in that particular position, they kind of didn't pay attention to that tiny detail. Student B does exactly the same kind of work. This time, student B's writing is not as good, but they make this same mistake of including 0. Anyway, the rest is totally fine, and that student earned 2 points as well. Student C would do a perfect job except for one thing. The derivative of e to the 2x plus 2 is 2 times e to the 2x, and here unfortunately they wrote 2x times e to the 2x. Besides that, it was fine, but of course they only earn 1 point out of 2. All of these students did a decent job in writing mathematically. Question C. Explain why f prime of 0 does not exist. I mentioned at the beginning that as soon as you see a piecewise function, you should automatically assume that several of the questions are going to be related to whether the function connects at x equals 0. So question A was, is it continuous at x equals 0? And question C is basically, is it differentiable? They even give you a hint. They say, why is it not differentiable? And why is it not differentiable? Well, we answered the question in A, in fact. Since it's not continuous, automatically it's not differentiable. So student A does that. F prime of 0 does not exist because f of x is not continuous at x equals 0. That was 1 point. And now I think it's time to have a look at the graph. This is not a calculator active exercise, but now we've answered several questions and it's worth maybe having a look at what the graph looks like. So this is the graph, and we saw in question A that the limit as x approaches 0 from the left is 0, and the limit of f of x as x approaches 0 from the right is 3. So disconnected. Now it's interesting to note that the AP writers had prepared something quite sneaky. Just in case students were going to calculate the derivative from each side, the one-sided derivatives, this is what they would have found. The limit as x approaches 0 from the right is 2 times e to the power of 0, and that is equal to 2. What I'm seeing here is this slope. The slope is 2, the one-sided slope. What do you find if you calculate the one-sided derivative as x approaches 0 from the negative side? This is it. The limit is also 2. And very clearly, that was a trap. If students were to calculate the two one-sided derivatives, they might have noticed, hey, this is equal to this, and therefore it's differentiable. That's not the case because a prerequisite for being differentiable is continuity. Had that piece here been down here, then this would have been a correct strategy to solve this question. It would have been continuous and differentiable. But again, in our case, because it's not continuous to start with, it's not going to be differentiable anyways. Student B also answered correctly. F prime of 0 doesn't exist because the function f of x is discontinuous at x equals 0. And student C did not earn the point. I think they probably had an idea of what was going on. It's written 2 values of y in x equals 0. It seems like they're saying that the one-sided limit, the two one-sided limits differ. They yield two different y values, but that's not good enough. Anyways, it doesn't involve any calculus, and it's not very explicit. Finally, last question. Let g be the function given by g of x equals the integral from -1 to x of f of t dt. Find g of 1. Once again, if we plug in x equals 1, because that's the question, what is g of 1, we see that we're going to go over the point x equals 0, and that's where many things are difficult. Student 1 does a perfect job. She writes g of 1 equals the integral from -1 to 1 of f of t dt, and splits that integral into 2, because the rule is going to be different from -1 to 0 as it will be from 0 to 1. If you dodge that bullet, then probably everything else is easier. The integral of 3x squared plus 2x is x cubed plus x squared, and the integral of e to the 2x plus 2 is 1/2 times e to the 2x plus 2x. And when you use the fundamental theorem of calculus, you reach the answer given here. Well done. That exercise was worth 4 points. The first point was earned by simply recognizing that the derivative had to be split into 2 parts, and after that, 1 point for each integral and 1 point for the answer. This is just a very a comment on the side, but I think quite often in exercises this year we've seen question where the boundaries of our integrals were a constant and x, and we've often practiced taking the derivative of such an integral, and I've seen some students sometimes do this derivative of the integral and say that it is equal to f of x. Be careful, this is something entirely different that is totally unrelated to the question here. Had the question been find g prime of 1, then yes, we're looking for the derivative, so the derivative of this. But definitely don't mix up things that are completely unrelated. Student B writes this correctly and then also recognizes that there are 2 different parts to consider in the integral from -1 to 0 and from 0 to 1. This is wrong. I'm not sure why that student thought it should be a minus sign, but they still earned the point, surprisingly, for just considering or just recognizing that we have to break the integral into 2 parts. After that, the student does another mistake. Instead of integrating, they take the derivative here and here too, so there was no other point earned. Lastly, the student here does a reasonable job at the beginning. They also notice that you have to split the integral into 2 parts, and they get the first integral correctly, but not the second one. Just as before, I think that student did. The derivative of e to the 2x was 2x times e to the 2x. Here, they write 1 over 2x times e to the 2x, so a foundational mistake here that was quite costly, not being able to integrate or differentiate the exponential function. By the way, if you substitute 0 in this expression here, it's going to be 1 over 0. I don't know if that student noticed or not. They wrote 1 over 2. They may just have hoped if they ignore the x suddenly, it's going to work out. But if you see something that doesn't work, look up in your calculations and think about what you did earlier, because there's probably a mistake. Okay, so that is it for this interesting FRQ with a piecewise function.